thanks, and thanks for having me. This is my talk on Infogrid's road to 1 million sensors and how our architecture's kind of progressing to get us to that goal. Okay, so firstly, just a bit about myself. So my name's Matthew Walsh. I live in Edinburgh, up in Scotland. I studied geography at university, and then I worked in computer mapping for a number of years. So I kind of moved sideways into software engineering, as I found I was basically writing code all day and enjoying that more than I was the maps. And so that's what I've been doing for the past 7 years. And I joined Infogrid in September 2020, so not too long ago, and I was developer number 7. So we've grown significantly since then. Okay, so what is Infogrid? So Infogrid retrofit these third-party sensors into buildings and assets. So then these sensors generate events, which our system or platform consumes. And then we provide a layer of intelligence on top of that raw data that enables smart decision making for the people that look after these buildings and assets. So the simplest example of this would be a temperature sensor. So you could install tiny temperature sensors in say a fridge. Maybe you've got medical supplies that need to be kept at a certain temperature, or food. And then our system can basically create an average of the entire fridge and set up alerts that would ensure that the building manager is notified if the fridge gets too hot or cold for whatever you're storing. Okay, so these are some of the sensors that we use. So we don't actually produce the sensors ourselves, the hardware. We use third-party vendors. I'll just show you one here. So that's from Disruptive Technologies. That's a proximity sensor. So you can see it's pretty small and unobtrusive. So these sensors have 15-year battery life, and that's if they transmit an event every 15 minutes. You can increase the frequency, so you could bring it down to say 5 minutes, but that's obviously going to have an effect on the battery life that you get out of the sensor. Okay, so how do the sensors work? Basically, they transmit using encrypted radio transmission. So the sensor transmits every 15 minutes to this, which is, you can't see it too well there, but that's the cloud connector. So once this has the event, it's connected with either 3G, 4G, or just Ethernet in the bottom there. And that transmits the events off to the vendor's system. And then we ingest those events from the vendor via a webhook. Okay, so just a few of the use cases that our platform can be used for. So people counting, obviously we've got the pandemic going on at the moment. So if you know the footfall or the room occupancy of a particular room, that can be really useful to stop kind of overcrowding, and just knowing that you've not got too many people in a particular area of a building. Desk occupancy is another one. So I think probably after the pandemic, we'll see that not everybody goes back to work in the same way. Maybe people will work from home, a bit more of a mixture of home and office. So knowing kind of how desks are utilized is going to enable kind of more dynamic management of them. So the way that works is if we take a temperature sensor, we've got take the readings from that, and we've trained an algorithm with TensorFlow that basically allows us to detect if somebody's sitting at the desk or not. So that's what I mean by a virtual sensor. And then finally, pipe monitoring. So if you've got commercial buildings anywhere with water pipes, these pipes need to be flushed pretty regularly to ensure that the water doesn't sit and stagnate. Because that's kind of perfect conditions for something nasty like Legionella bacteria to form in. So yeah, just using a combination of temperature sensor and a water movement sensor, we're able to check that that those pipes are being flushed in accordance with the regulations. Okay, so this was our kind of initial architecture. So start on the left here. So like I said earlier, the sensor vendors push their raw events to our ingestion service, which is just a basic Python REST API. We take these events, put them into our own internal event format, and store them in DynamoDB. And then we've got a web app stack. So we use Django REST framework with Postgres, and then React for the front end. And then any event data we need, we can just retrieve from Dynamo. So you can see there I've included a bit of JSON for like a raw event format. So kind of thinking for going with Dynamo initially was it's obviously really scalable, being NoSQL, and because it's AWS, it's high availability, so kind of don't have to worry about the headache of managing it yourself. AWS takes care of all of that for you. But the cons were it's kind of not so cost effective when you start getting the amount of data that we're putting into it. But the main one really was the ability to query the data. So obviously all this data we're gathering is our kind of biggest asset, and to not be able to query it in a kind of efficient way and get the information out of it that we need is not ideal. So looking forward to where we're going, where we plan on going. So we've got a target for our system to support 1 million sensors by the end of the year. So 1 million sensors equates to 251 million events per day. So yeah, that's a lot of events. And then on top of that, if you've configured any alerts for sensors, so like I was saying earlier, you could send a text message or an email if a sensor reaches a certain threshold for a certain length of time. That in turn produces more events, and then the virtual sensors that I talked about earlier, they also produce events themselves. So yeah, you can see that maybe by this point Dynamo maybe isn't the best solution for us. Okay, so we came up with the concept of creating a data lake, which you're probably familiar with. So the only thing that's changed you can see here is instead of pushing the data into Dynamo from our ingestion service, we push it into Timescale DB and into AWS. So for Timescale, that's really good because it's meant for time series data. So it's based on top of Postgres, but handles time series data really well, really fast for querying, and lets us query in SQL, which is much better. But it's not cost effective to store everything in there with the amount of events that we've got to store. So we keep events in there for up to 3 months, and then past that, we store those events in JSON format in S3 buckets. So we use S3 and S3 Glacier. S3 Glacier is obviously slower. It's meant for kind of archiving your data. So it's slower to retrieve the data, but that doesn't really matter for a lot of the use cases of the older data. It tends to be like yearly reporting or some kind of aggregation that you're doing over time. So it's not kind of time critical queries. And then we use AWS Glue. So what that does is creates a data catalog for us. So we kind of partition this data on S3 by sensor and by year. And then we use AWS Athena on top of that to query the data. So this is really good because it lets us query in SQL, which yeah, obviously is just much better than Dynamo's kind of querying capabilities. So as a kind of overview, that what the data lake gives us is a better sliding scale of controlling the cost. So that's going to see us, I think, much better going forward. Obviously, this is just kind of what one aspect of our architecture I've looked at here. So we've got loads of other challenges coming up to kind of scale the different parts of our system. But just to give you a kind of flavor of what's coming up next for us. So we're looking at creating a healthy building dashboard. So you can see there in the picture that will have like floor plans with heat maps in it, so you can see averages across a whole floor. and just get a holistic view of what's going on in a particular building. So that's really good for environmental, social governance. We've also got new sensors coming on board, so vibration sensor, lighting sensor, and then sensors that will log more frequently, but still send the events at the same kind of 15-minute time period. But it gives us that more granular data for us to analyze. And yeah, so I'm sure there'll be lots of exciting new ideas we come up with to use these new sensors and add value. Yeah, so I think that's my talk. Thanks for listening.
Thanks, Matthew. Magdi had a question. What are we planning to use for the dashboard? Any particular AWS tech stack or bespoke?
For the dashboard, I'm not actually too sure yet. I think it's to be decided, but we tend to stick with, our decision making tends to be that AWS tends to be the easiest way to do something. Then we would use AWS. But then further down the line, as we found out with this, it's maybe not always the cheapest option. So, yeah, not too sure we'll use that yet on that one though.
Yeah, and Omar earlier, and you can see this question on the stage tab as well, had a comment that if you go serverless with Python Lambda, you can do it all in a map, reduce fashion on top of S3 and Lambda as compute layer, most neat, lean, and cost effective.
Yeah, I mean, I think Lambda is something we do use. Yeah, it's certainly, I guess the disadvantage of that is that you kind of tie yourself to the serverless way of doing things, which could be a risk going forward, I guess.
And there's also a question from Russell. Are all the real-world applications building facilities management, or have you looked at stuff like agriculture?
So at the moment, I think it's more facilities management and asset management, but I think certainly in the future, if there was enough demand for something like agriculture, that would, yeah, certainly be something we'd look at.
Yeah, and Ilias has a question: Do data like temperature, etc., come from varied sources?
So if I understand correctly, I think yes, in that we can have multiple sensors. So yeah, sometimes, like I said, with the Legionnaire's pipe monitoring, that's taking data from like a temperature sensor and a water movement sensor, and it combines them together. And yeah, we can take like averages, so we can group sensors together. Like I said earlier, in a fridge or something, if you've got maybe 15 sensors in a huge walk-in fridge. So that's the kind of data sources we use.